Okay. So, um, yes. Yes, I'm here. I'm back again. It is now earlier. I'm probably not going to be here for very long because I have other things to do. Unfortunately, stupid real life. Fucking, it's stupid. So I went back and looked at my previous stream, and I did a really terrible job explaining what this thing does. And so I'm gonna just illustrate it here. Here, okay, I'm gonna switch tabs, or else I'm gonna like distract myself. Uh, so, oh yeah, DND. Don't remember to turn that off, so I don't get spammed. So basically, here's what it does. There are kind of three parts. So you have your input. Okay, it's gonna be awful, but that's okay. It's all good. So you say you have your input waveform, and then what you have to do is this is currently AC, which means that if this line is the 0 point, then up and down it's like this is a negative number, this is a positive number. So the first thing I need to do is get the volume, and I do that by rectifying this, aka making this negative part positive like that, and that just uses like absolute value to do those. Beautiful. I'm an artist. And then what it does is this is the volume function. Currently this compute volume, so it rectifies the waveform, and then whenever, say, the volume little thing is here, it's just another variable over time, and as it gets to here, it follows it when it increases, but when it decreases, instead of following it down, it slowly fades off, and then it increases again, and then it slowly fades off, and then it increases, and does that. And so this is kind of like a capacitor in a way, smoothing capacitor, in the fact that it does that. But this basically gives me a relatively smooth signal of the waveform over time that is a lot nicer and less jumpy than the actual rectified waveform. If you look up, okay, AC to DC, just look this up. This is basically what it is, except instead of using diodes and a capacitor, it uses an absolute value function and an if statement that checks if it's increasing or decreasing the waveform. Yeah, here it is. It takes the waveform, rectifies it so it looks like that, and then it smooths out like that. Basically, it's just that. It's just an AC to DC converter. So that's cool. And then what we do with this is here. Let's get rid of all this crap. So now we have a volume that let's just draw it nice and smooth and inaccurate. So that's our volume right there. And then we have a threshold, say at like here. And when the audio is over, when the volume is above the threshold, then it will amplify the volume to be at 0 dB. And then if it's below it, then it will gate it and just silence it out. And you're like, well, then that will look pretty awful, right? Because then wouldn't it just look like that? And disgusting and terrible. And yes, it would normally look like that. But we're preventing that because we're also having another separate kind of gate thing and amplifier thing that also kind of has a similar functionality in the way that it has a release and it kind of follows the volume, so it slowly gates away and then brings back, or it slowly amplifies and then doesn't amplify, and that makes it nice and smooth. And that's basically what a compressor does in the case of just gain and then just like limiting, except without the gate part. I could probably do this with like an audio effect, honestly. I could probably do this whole thing with an audio effect instead of making my own program, but I just don't feel like it because I want to challenge myself and be an idiot. So yeah, that probably made even less sense. Here, I'm going to try to explain look ahead now. So you have your waveform, and it's here, and it starts quiet, and then it gets loud suddenly, right? And say you have a line that wants to follow it, and you want it to be kind of smoothish. So what you would do if you didn't have look ahead is it would okay, ignore this part, ignore that part. I can't draw, so that was terrible. If it was quiet like this, and then you had an attack on the volume when it was following it, then what it would do is it would, instead of shooting up like that, it would slowly go up to follow whatever the waveform's doing in this case. And then if it went down again, it would slowly follow it back down. But see, then this ignores this part here where it's loud for a moment. So what we want to do is instead we want to be smart, and we want to have it to start to increase the volume before it gets to the loud part. So what you have to do is you have to say like, oh, okay, you have to like know that it gets loud at a future point in time, and then you have to like ahead of time slowly increase the volume to get to that point. And of course we can't just look ahead into the future because that's just impossible. We can only kind of have a snapshot of the past and a relative present. So what we have to do is we have to capture a certain number of samples, and then depending on the attack, how long it takes for that attack time to go up to the sample, we have to capture that amount of samples beforehand. And then so when it's like, okay, there's going to be a loud part, then we will increase it ahead of time, but it's really not ahead of time. And basically this results in the fact that it basically just results in delay because you're capturing some samples first and then you're doing stuff on them. That's kind of a bad explanation as well. But basically you have to, it's kind of a mock way of looking ahead in the audio into the future, except it's not into the future. It's just like everything's delayed, so that the future becomes the present, and the present becomes the past, which basically just means delayed audio. So that's what that does. That probably wasn't a good explanation. In fact, I might have just found a flaw in some of my code and how I'm going to do this at some point. But we'll cross that bridge when we come to it, right? Okay. I also haven't had any food, so I'm gonna be hungry. So far we have the volume, and that took an obscene amount of time to create for some reason. I don't know why it took so long for me to do that, but it did. And now it works. We're not doing attack on the volume because we want it to follow the volume pretty closely, like an AC to DC converter. We'll probably put attack on the gate and the amplifier, but for now we won't because that requires changing like a bunch of code, and I just don't feel like doing that, you know. And eventually we're gonna get a visualizer in here when I figure out how to do that. Speaking of figuring out how to do that, I might have actually figured out how to do that last night. So last stream I said that I said that, oh man, this doesn't work because we have an animation function right here, and it is called every so often, and this thing here, this plot.show thing, blocks, so this doesn't get called to draw stuff to it until the end. So basically it's like, oh no, now it's synchronous because this draw frame is getting called. This is the only point where stuff happens. Other than that, it blocks. And it's like, well, if it's synchronous, then why don't we just make it asynchronous by shoving it all in a thread? And to be honest, I want to try that now, honestly. Because, so threads in Python, so, okay. So you have applications which are actually called processes. This is a process, this PyCharm ID, this Notepad++ is a process, this Git Bash is a process, Google Chrome's a process. Actually, Google Chrome's many processes, but that's not important. And then processes can have threads. So each process has like a different space in memory that it can work with, and if you try to work with space outside that memory, you will not like you. The operating system will yell at you. And so, but with threads, they all share the same space of memory. It's just that they can execute concurrently. So a process can have many threads that execute concurrently that all share that same process space. And so they're useful for stuff like this concurrentness. But advantages to them, they have less overhead in creating them. But a disadvantage, a big one, at least for me, is the fact that you can't just shut off a thread. Like you can close a process. You can just force shut down a process, and you can do that with Python. But you cannot do that with threads. You have to wait for it to stop, or you have to like set a variable, and then it has to check the variable, and then it's like, okay, this variable is set. I'm going to stop my thread now. But if it's doing something, it's, instead of checking for the variable, if it's doing something else currently, then it won't stop. So, there's advantages and disadvantages to both. In this case, I'm not really going to be having to force stop it, so a thread will work nicely in this situation. Also, thread safe stuff. I'm pretty sure Python's pretty thread safe, and as far as I'm aware right now, if I'm not stupid, then I believe this isn't really doing anything that involves thread safety. Because let's see, counter. Yeah, locks thread safety. One of the ways Python does thread safety is with a global lock. I'm not entirely sure how it works, but it does something. But usually what you do in the case of thread safety is, like, if you're incrementing a number, then you lock the thread so you can only one thread can increment it at a time. Oh yes, here's where thread safety comes in. Say you have, okay, we're gonna have another stupid thing. So say you have two threads. You have thread A and you have thread B, and there's a variable here. So you have a variable there. That's awful, but and it equals something. And so basically the way programs increment things is, so a thread to increment a variable would take the current variable state, add to that state by 1 if they wanted to increase it by 1, and then store that back in the variable. So it get the variable's current number, increment it, and store it back in the variable. The thing is, what happens if two threads are trying to do that at once? So if thread A and thread B are both trying to increment at the same time, then what will happen is it will be stupid and not behave expectedly, because because this thread will get the variable, which is currently 1, and this thread will also get the variable, which is currently 1. Then this thread will increase it, and this thread will increase it, and then it will store that increase back into here, which is 2. And then this one will also store back into here, which is also 2. So what you might expect to happen is, oh, if they're both increasing it, then shouldn't this be 3? Because they're both increasing it by 1? But no, they're not. Because I just explained that. The way they both get it at the same time, increment it, and then store it at the same time, makes it so that, no, it only gets increased once. And that's basically just thread safety in a shellnet. And so what you would do to solve that is you use a lock that basically just says no other thread can touch the variable at a time, and only one thread can run right now, and then let it increment it, and then release the lock. But this isn't doing anything like that as far as I'm aware, except for appending. Okay, well, it's adding to it. It's modifying an array, but it's not like two threads are trying to modify the array at the same time. One thread's trying to get it or modify it, which is this thread is the draw thread that we're going to make, and it's going to get the array, but it's not going to modify it. And so, but then the main thread is going to modify it, so only one's modifying. So it should be thread safe still, which is a good thing. So if I'm not a little ding dong, then I should remember how to do this pretty well. So this is a draw thread. So what we're going to do is threading. And actually I can just do thread, just import that from threading, because it's not like we're going to be doing any other threading stuff. Thread, the target is draw thread, and that is a function. That way it's going to be called, we're not using parentheses here because it's going to be called later by the thread, because functions in Python are just objects that have a callable method, or a call method that you use to call them and supply them with parameters. The name, I mean, I don't really need, you don't have to have a name, but if you want to, if when errors happen in that thread, it will say in thread and then the name. So that's how you know what thread it is, instead of in thread _1 or something, arbitrary and hard to understand, relatively like that. So this is going to be Damien equals true, or Daemon, I don't know, I call it Damien, but that's not the word. And I'm pretty sure what that basically just means is, if I remember, I haven't done threading stuff in a little while, is what that means is that when the main thread stops, yes, okay, so Damien, which is not what it's called. Okay, how do you pronounce this? I don't want to keep pronouncing it wrong.
Demon.
Demon. Okay, I'm gonna pronounce it demon then, or daemon. This basically means, if this is false, then when the main thread stops, aka when this part stops, aka when the program stops, then actually it won't stop. It will wait for the main thread is just the program thread. When you don't do threading.thread, that's just the main thread. If this is false, then when the main thread stops, the program will wait for this other thread to also stop before stopping the entire program. If this is true, then when the main thread stops, it will just stop all of the threads. It will just shut it down. And I want that now because I don't want to wait for this thread to stop. So, and I usually do that for the threads like those. And then, so join, I'm using start. Join is a blocking one. It's kind of dumb in a way. But it has uses, I think, where it waits for, join waits for the thread to stop before moving on to the rest of the code, or aka this part. Start just starts the thread. I want it to do this and start this thread, and then also do this at the same time, so I am going to leave it at start and not join. And so if I'm not a little ding dong, then if this works with threading, then it should work. Okay, so that makes sense. So here is our current problem. Oh Jesus, getting some errors on the server. Nice. Okay. POI. Nice. I might have to update the server actually. Hold on. Sorry. Distractions. Is there a new version? Q and chunk map. And that was yesterday. I just didn't get that one. That's okay. It's all good. This is happening, and it's like, okay, so this is shapes 199. This is an array of length 100. This is array of length 99. But what? No, it shouldn't ever get an array of length 99. Here's the reason it's doing that. Because what this is doing is really hacky and cheaty. First, it removes an array from the beginning of the list, or not, the beginning of the list by using pop index 0. And then it adds the new sample to the end of the list. And so at the end of this QDraw function, the list will still be length 100, and it will have shifted that value in, the sample in. But what happens here is, since again thread safety, this popped the thread and made it length 99, and then this draw function was called before it appended here. So hold on, I know there's a way to do locks, and that will be useful in this case, because we will want to lock this, I believe, before modifying it. Or I could try to do a less cheeky method here, but I want to do locks for now. And I'll just import threading instead of doing like sub imports or whatever they're called. Oh yeah, okay, all right, that's an exception there, but if you go up enough, then at some point it should. Okay, that's fine, that's all good. Global interpreter locks, yeah, okay. primitive lock is a synchronization primitive that is not owned by a particular thread when locked. Lock is one say it's created and allows it to acquire and release. Change the state to lock. Locks. State is unlocked. Acquire changes state to lock and returns immediately when the state is locked. Acquire blocks until a call to release. Thread changes to unlock and then acquire call sets it to locked and returns. The release should only be called in the lock state. Re-enter lock is a sacred acquired multiple times by the same thread. So is there a way to lock that? So, okay, hold on. Python threading lock example. I want that. No, not XML. Example. So what happens if I just use one lock instead of doing all this stuff that it wants me to do? So that will lock it, then it will. And does locks work with statements? Enter and then exit. So yes. Okay, lock. Okay, and that is the binding, Python binding for the C threading thing. So can't just do that. Oh no. Locks. Can I use with on lock with? Or would I just want to do just the, yeah, here it is. Conditions, Cephomores. I don't know what Cephomore is, but that's okay. I do not need a Cephomore right now. Acquire and release methods can be used as constant management with statement. Acquire method will be called when the block is entered, and release will be called when the block is exited. Hence, the following snippet will look the equivalent to some lock.acquire do something some lock. So with statements is the way to go on this one. With lock. And that. Cool beans. So this is using toDraw here. So we will want with lock. And that should prevent the thing from being stupid. There it is. And we don't want to print that. Okay, so that is really laggy and kind of not working at all. So just do sleep. No, not async IO. We want time.sleep. We will do 1 divided by 60. Look at that. And that's epic. Awesome. And that, so that is when you draw at the same rate. I like how the interval can be 1. Oh, because if you do 1 divided by 1,000, it will go quickly. Can I do 0.1? Or does it have to be? Okay, so it has to be an integer. Interval number delay defaults to 200. Yeah, okay. So if we do it at 1, that's the fastest it can zoom. And if you do anything more than that, then okay, Okay, so 1 is the lowest it can go. And that, here we can scale, we can actually scale this. How do you scale? What happens if we do 2? Let's just set that to 2. What will happen now? It will indeed have, it will allocate space for a, yeah, so that does allocate, or not allocate, but allow space for those other plots. But we only want 1 plot right now. So epic, that's probably just is that destroying my Python very high? Yes, that is probably sucking up power. I could imagine doing all those draws like that. And so that what happens if we do dot join? So that should draw like just nothingness. Cannot join thread before it is started. Alright, fine. So we'll just cheat. And we'll start it, then we'll join it. So when you close it, this one, yeah, this is the blocking call, plot.show. So when you close it, it will do stuff. Could I just shove all this out here? And would that do the same thing? Because the blocking one is this one. Main thread is not in main, in thread, draw thread. Create command, main thread is not in main loop. That's probably getting mad at me because the plot.show is not in the same thread as the figure doing thing. So no, we can't do that. Hey though, it was worth a shot, right? It was worth a shot. But no, it does not like that. But yes, this is the blocking one. So when you X close the window, then this will stop blocking, and then it will be done, the function will be done, so the thread will close, and this join will be completed. Epic Mimi time. So that does what we want, albeit probably not very well. And if you do not sleep here, then it just... Here, wait, let's just do Python shift list. NumPy.roll. Actually, that'd probably be a better idea to use NumPy, because NumPy arrays are meant to be like, they are optimized to be NumPy arrays are not optimized to be fixed size, and if you try to, they don't actually have an append function. You have to, oh, there's a cat up here. Hello Pepper. If you try to append to it, it will work, but there's no like method. There's like a NumPy function to append, but it will create a new array of the different size, and that will create a lot of overhead if you do that a lot of times. In fact, so it will be much lower than if you use a list.append. So again, basically all this means is that that should be spelled zeros with an E, but it's not. That's not what that means. Yes, hello. Yeah, I can't pop append, so. Are these threads safe? Do I need to use a lock in this case? Because no, I probably don't, maybe. There's a chance I don't. Let's just try deleting the lock for now, and we can always put it back. to draw. Can we roll that? No, we can round it. Can we rotate it? Can we shift it? No, that's bit shifting. What does numpy.roll do? Roll array along a given axis. What is roll versus roll axis? Backwards until it lies in a given position. So we just want to roll that. So we want roll, not yes, roll. Don't take the little squirrel thing. I know you like the squirrel, okay? But it's my squirrel. Pepper, this is my squirrel. Stop it. It's Pepper. Good girl, but please. I have no control. I mean, at least she's going now. Bye, Pepper. It's not like I used the squirrel. Number of places in which the element. So I just want to shift it by 1. But it's not. Does it create a new array? Okay, Ravel. I've heard of this. Return a flattened array. Flattened. There's a difference between flat and Ravel. One of them I'm pretty sure returns in place, and one of them doesn't. Flatten returns a copy. Ravel does it in place, or it just edits the original array. So I'm pretty sure that's just in place. So it actually does an in place flatten. And then it rolls it. Unfortunately, that roll there. Is not. It's probably going to be really slow. So let's just try rolling it. And if rolling doesn't work, then, it doesn't have to be perfect. Dot roll to draw. Now, how do you shift a number into it? Oh, and it doesn't return. It doesn't do it in place. Yeah, so that's probably gonna be really slow because there's gonna be a lot of overhead there, and you can't pop a new element into it. I just want pulling and pushing. So DQ is meant to do that. How do you roll without? I don't want to copy. I wish there was a way to rotate it, but shift, and it says shift something into it. Okay. Let's just try, instead of using this, we will use a list again, because they are more mutable, or I mean, they can change sizes nicely. To draw equals to draw. So let's see. This is going to there. What is the problem? Unresolved reference, because I need to use a global. Like that. To draw -1. So what that'll do, no, we want an element at the end of it, right? Yes. So that will return up to the very last. So that'll basically just remove an element at the end, but then it will plus sample technically, if I'm not a nutmeg, that should do relatively the same thing. And we're going to do 1,000 divided by 60. And we're going to use time.sleep again. Just cause. Maybe it'd be easier if we did 10. $110 samples to draw. Oh, because I should have just done that. Excuse me, cat. I'm trying to work here. Oh, wait. No. We want to take the first sample to the end because we're going to shift all of them, so that would be that way. Yes, okay. I want 100 samples. Samples. Not how you speak English. So now if I do this, then that will probably lag still, but it will be... it will still be pretty laggy. Okay. Can you say, like, is it like dot joined is alive? What is the difference between is alive, those two functions? Deprecated. Okay, well they're the same thing. It's just one more Pythonic naming scheme. True just before run method starts until after the run method terminates, and the run method is where the function is, because threadings are objects that do. You can have threading classes instead of using functions, but I don't want to. Nobody is here. Just me. No. I don't want that. Now nobody is on the stream. Where was everybody beforehand? People were here. Nobody's here now. Maybe it's because it's the morning, you know? Maybe it's just the time of day. Oh, the phone's ringing. Good. Goody. Inserting and popping is not fun for me. Okay, alright, well, if that's the fastest I can do, what I want to do is I want to maybe, might be a problem. Man, it is 36. I have PLS pretty soon. I should probably get something to eat, or take a shower, or do something. But I just don't want to. Really. I'm just gonna use a lock, maybe. That works, but it doesn't work the way I want it to. Really. Is there a better way, like adding multiple samples at the same time? maybe I can, like, because now I'm making a range every single time. It's creating a new list. Stop. Do not pull that off. I need that. I want that. And is that jewel that I feel on my finger? Yep. I can probably just get rid of that. There. We have more constant values, which might be good, and it might not be good. So currently that's just not doing anything. Okay, we're going to start tagging these so I can get good auto completion. What does that return? Axis.subplot base. What does it return? Returns. It doesn't. Okay, that's why it's not showing correct documentation. Because it's looking up online instead of using the comments. Or is it because no, it has it. It's just a ding dong. Oh, subplot base. Still does not give me anything. Okay, then we're definitely going to be using the base. Because that absolutely does stuff. And then it's going to get mad at me. Oh yeah, nice. For not having the functions that I want. Okay. I thought you returned or a subclass of axes. Yes. So axis returns axis a subplot base base class subclass of axis. There we go. Yeah. Hold on. Doesn't that I thought that subclass access. Isn't that what you just said? I guess not. Alright, so then we are lied to, and it actually add an access.access, so it is definitely just access. Because it has the functions that I want, it has everything that I want. And hold on. Can we just do xscale samples drawn plot dot y scale? No, just don't freeze, just thank you. And that's gonna just be value. So you can provide a tuple, or you can provide the left and the right. We'll just have to go from 0 to 1 then. It appears to not like that. Or that. Have I broken it? By putting X's up there instead of that. That shouldn't have broken it. Should have it? I don't think it would have broken it. It worked for just a moment. I don't know what happened. So you have to but if we don't do anim, then it gets what? Why does that variable matter? Why does it matter what it returns? Why does it matter that we have to have it as a variable name? Because if we don't have it, then it doesn't animate. Yeah, it just doesn't get called. But if we set it to something, then it gets called. What? That doesn't even make any sense. Why would it check for something like that? I mean, okay, whatever. I'm just, it's a little confusing, I guess. What if we do 200? No, okay, so that's something the subplot has to control over. So why, my question is why does that not work? Do I have to set it every time? Does clearing reset the limit? Does that? Okay, so they're negative now. That made it negative. And that. I want to know what ion does. What does that do? Interactive. So that's interesting. You don't even need a thread in that case. Instead of using that. Plot? Block? Okay. Doesn't that usually require? Huh. So. Plot appear non-interactive. interesting. How peculiar. Okay. Make the plot appear. You need to do this. Blocks. So good at this being forced to use block. I'm supposed to need place files. You want to look at the block. Okay. No, okay, well, I'm gonna have to go to breakfast, so. See you later, I guess. Here, just for fun, I'm gonna tell people I'm streaming. Should be on that window. Eventually maybe it'll decide to connect itself. Sorry, feedback loop XD. Okay, so currently I am doing drawing stuff. Also, here wait, I can demonstrate what I want to do in terms of attack and release much better with something like a square wave or something that I can more easily control. So not sampler, let's just get us through. And open up just a free limiter. So I can detach this and bring it to the other screen. Sorry, now I have deleted it. But it's just that's not important. So that is the ceiling is down there. Cool. That will work. That will work. Huh. Why does it just jumps up? So release. What does release do then? Does that just? so you can see here, this bar is this is a limiter, and the bar here is like the gain reduction. So I'm not showing the outward rate right now, and also I've set the ceiling to low, so whenever there's any sound, it will just reduce the gain all the way to 0. But so I'm not sure what that line is. I think that's just 0 dB, and so usually doesn't do any gain reduction. But when I play something, I have the attack really high right now, and I don't know why it does it on both ends, but whenever I play it, it delays. So I'm pressing the I'm making a sound now, and then it goes down and reduces the gain. But you see, it's like what this is supposed to be doing is demonstrating look ahead, and the way it does that is because it lowers the gain before playing the note or before having the sound, which will make sure that it will always limit it. But this means that there's a delay. Hold on, I'll be right back. Okay, so that's look ahead, except it's kind of oddly shown. So that's unfortunate. But whatever. All's good. All's well. I really just think this drawing thing is the thing that should be done first before anything else, because it will be the easiest way to visualize what I want to visualize. And I should probably also make this Pi Audio thing controllable instead of using an audio stream. So it's gonna be more splitting up. Just use global variable. just getting mad. Function should be lowercase. Let's move them out there because those are constants. Do I have to put the p string in here too? No, I don't, because I'm never setting p. If I do that, then I do that, then anyway, just doing equals there. That will be useful. Now I can get this out here. Chunk, and then we will do nv.fromString, and that will get mad at me for it will say won't that yell at me say, oh, it's deprecated. Deprecated from string falls back. Argument is not provided if the separator is not false with them. So we should use from buffer. And then right chunk is numpy array. And then stream.write chunk numFrames equals chunk. We don't really need to provide that probably. So that did that. Okay. We can do all this later. I could probably, instead of using release, I could be cool beans and use like peaks of the waveform to get different volumes along each point, each peak. And then, so another thing I could probably do is if you have your waveform here, then after rectifying each part, then I can just take each peak here and then linearly interpolate between each peak, which will give me an extremely accurate audio, like a super accurate audio representation or volume representation. Here, you put this. I'll just keep that there for now. we're going to be doing audio dot read and then audio dot write chunk. I just realized, how will you change that? That will have to be something we'll do later. Again, this is really terrible at the moment. Yeah, okay, I don't care. Shouldn't you still do things? Shouldn't you be auto-completing? You auto-complete there? Is it because Heroid? So it just ignores syntax. In that case, okay. Audio dot init. Let's accurately rename. Cool. So now that kind of puts that in a nice little area for us to do stuff to it. Okay, back to graphing.
First of the final section, 5, how to see the different kinds or within the Jupyter Notebook slope of 10. Now we can argument of 0. should we occur.
Oh, because I have to pause. Yes, now I'm remembering this. It's been a little while since I've done stuff like this, so. Okay, so yeah, I'll just break there. That's what works.
Okay, that sounds good. I bet you would. Thanks, Adam. Have a good Fourth.
Do I have to Python?
Well, hopefully it's not raining. Yeah. All right. See you next week.
Well, why don't we interact right now? So. Nothing's perfect. In fact, this is a numpy.array, right? Yes, it is. Okay. Cool. So we're gonna use. We'll just get rid of all these for now because they are non-important. We're really gonna minimize things here. In fact, we're just gonna get rid of that too. We'll just use plot there for now. Again, we will change all in due time. Let's just go. Let's just use a square wave. Actually, we'll just take this read, and we'll do. It's all good. Huh. So we'll just do sine. Cool. All right. So that should return what we want, and it does, indeed. Okay. And we are also going to plot a volume. Yeah. Have I been? Oh no, I've been looking at the wrong screen the whole time. Oh, that's annoying. Oh, I'm sorry. Oh, jeez. That's unfortunate. Oh, everybody's just been looking at this the whole time. Oh man. Oh, for like 10 minutes too. That makes me sad. I'm sorry. Okay. I was afraid I was gonna do that at some point. Doofenshmirtz. Nice. Thanks, Doof. Okay. So we have a fake thing here that generates a sine wave for us, which gives us much nicer.
So, remember how when you would use your own shower, the main and you there, we're not brushing.
Sorry. I guess you know what? It's not that bad. Why do I even care? Shit, it doesn't matter. Honestly, it does not matter. There. Cool. previous one, if sample is bigger than the previous one we read to, then the current one so it's iterative. So it, there we go. Cool. So that does exactly what I want it to. And now it visualizes. Alright, well it's not live, but it does what I want. And if I change the release, then it will do that. So that works. It's definitely a lot more smooth, but so it's more smooth other than just going like that and doing that, which would just rectify it without smoothing. So could I just plot the wall buff like that? Oh, that, yeah, okay, that's kind of glitchy, but cool looking. Wow, that is terrifying. If we do it for every sample, well, that's just gonna lag. I'm not even gonna try doing that. Anyway, that works enough. Still really jittery. Wonder if there's a way to do it better. Other than changing the release. Didn't I do this at some point? Wow, look at that. It opens a stream and it writes to it and then it closes it. Oh, that kind of hurts a little bit. Oh, I guess it just writes all the samples, not in chunks. Here's a cool thing where it does cool stuff, because it's not that, although that does work a little bit well, but not good enough. I know there's a way to find minimum and maximum points, because I've done it before with PyPlot. It might be in here. More from, yeah, a bunch of audio functions that I made back when I was using PyDub instead of PyAudio. Minimum and maximums. So here's another way of doing it. We're going to be using a little bit of math, and we're going to find the relative maximums. Actually, we can just import that later. we can just compute the volume once, right? And that will do the same thing, yes. Except each thing will have its own for loop. Cool. Case. Just me. Just me. Okay. So, now what? Now what? Now what? Now what? Now what? Now what? We're gonna find the min, max, min, boop, boop. So there. Now, let's do that. Equals the maximums of absolute value of chunk. The chunk. And if we do pi plot, plot peaks, will that not do that? I see it lags. That's annoying. It's very annoying. No, instead of plotting, we just print peaks. And is this, sorry, this returns indices. Interpolate. down, and 2.5 should be also going there because it reads too. So that works. Hit those indices. Do I really need my microphone on? Just for fun, I'll have it on. Okay. Why does it return a tuple of ND arrays? There. Now to lerp between them. I equals interp. Hello. And that's beautiful. So that works a lot more nicer. Except for there. Why doesn't it get that point right there? Let's just do absolute value. Just for good measure. Because that's on 0, so it doesn't count that one as a peak. Of course. And nor would I. Okay, that makes sense. What? Paper. My goodness. Now you're really soft. Don't drool all over everything, please. But This might not be real time, but you know what? I've kind of sacrificed that at this point. So what happens if I actually get the thing that I want now instead of faking it? Just go. Wow. So my question is, where is it getting that? Is my absolute valuing getting rid of some of them? I feel like it is. Oh, it is. Look at that. Look at that. So really, I should be getting peaks of minimum and maximum and then just absolute valuing them. Oh, they're just random values, of course, because I didn't initialize them. Okay, we're just going to zero them out for now, just because it will be faster. Okay. Let's put the fake one in. just stop the code there. So there is a concatenate function. I was right. Huh. Because I need to something like that. If we get rid of it, then we'll do a 2D array, which I do not want. Oh boy. Oh boy. Alright. Oh boy. What's going on? What's poppin'? Oh. So it goes whoop and then whoop. Except those are peaks. Now we need to get those boys as well. We need to get both boyos. Sort. Conjugate. No. That's not what I wanted. Why did we just do that? Just sort it. Just. This is why at format string must not be none. What are we sorting? Kind. Quick sort. Yes, we want to sort. Sort them. What is merge sort? Hey, Pepper, can you please stop? Stop it. Stop it. We'll do sort. Multi-array. Huh, okay. Quick sort, merge sort. What does merge sort do? Don't care. Okay, it's just another algorithm. So what's problem? Compute var, plot that. Must not be none. Don't knock my microphone over, dude. Sort. There. That works. So it's bad. So I'm gonna absolute value these, and now it should only be positive. Excellent. Now it gets all of them, including the little boys. What happens if we just do, alright, x's, and then x's, like that, and then we do x's equals abs chunk. does that. Which is not what I want at all. I want it to do this one, okay. We're gonna do, yeah, okay, that works. And then abs chunk X there. No, that's not what I want to do. Abs versus numpy. What is the difference? Okay, well that'll have to work. Cool. So we will sort it. And we'll do that. Epic. Do we need to interpolate it? Yes. Why? Because we need to, because we just do, right? Yeah. Epic. Now it is really getting all of them. Each and every single thing has been got. See, I would say that's a maximum, but according to this thing, it's not. See if I go like this and I say, okay, no, arg-rel max 0 chunk, get rid of that. Then it gives me those boys. If we do arg-rel min, then it gives me those boys. So which one is better? There's less computation on one. If we do absolute value, well then it does that. If we do that, then it does that. Which is kind of blech. So if I get rid of the fake boy and then go, oh, I forgot to do, okay, to do it really enough. And it does that one. And for good reason. Now, is that really something that I want to see? If I go this one. Then great, it gives me what I want. And that makes sense, that follows a lot more accurately. But if I go, then it kind of follows accurately, sort of, except that one. So the best probably thing to do is that. It's more accurate. But it requires a lot more work. Those peaks must be pretty identical then. That's funny. That follows it exactly. Maybe that's not good. Maybe we don't want it to do that. Well, we do want it to do that. Do we? Do we want it to do that? I'm not sure. Because that goes up and down, up and down, up and down. Okay. But that's following it really closely. Preferably, you would not follow it that closely. Preferably, you would not do that. is way too closely followed. Okay, you know what? That's still pretty closely followed. I think we would go for the easy way, which is just that. X is equals X. So we rectify, we find the peaks, and then we get the values of those. And you know what? It's just gonna have to work. It's just gonna have to work. It's like, it's not getting that one. It's not getting that one because that part goes up like that. And now those are the maximum points. And that's actually a minimum point. But would you really say that's the way it is? Yes, I would. We're keeping it like that. That's gonna have to do for now. Doesn't require a release. Oh, but it will get rid of the fundamental frequency. So now we're gonna do it. We are gonna do it like that. Maybe. Because it might be faster. It actually might just be better. I might just be a stupid idiot. Honestly, there's a good chance I'm a numbnuts. For now, that is good. This is going to be based off the volume buffer. Honestly, what am I doing? What am I doing? This is going to do a where for each. What? Stop. Stop. Stop it. Doesn't help. Pet the cat. Just can't pet. There's no choice. You have no free will. This is just really going downhill. Like, the more I work on this project, the more it's just like... But, you know, that's just what happens. What happens if we just print this? When is volume buffer bigger than the threshold? That doesn't even do that because I didn't. Stop. That's why it's not doing anything, because I forgot to call the function. Nice job. So that's a gate, but now we need to smooth the boy. So when it's bigger, sorry, did I say bigger? I meant smaller. I really just do it at this in chunks, where I say like, oh, for this whole chunk, get the volume is literally just the maximum of the chunk. The gate is the, like, the thing. The volume is the maximum of the chunk. The gate is it, and then the gate still depends on the volume, and whether it's, and if it's the max value is lower, then it will gate it, and if it's not, then it won't. But then it won't be smooth. Then it will be beautiful and smooth. I could always just have it be beautiful and smooth by going by chunk, and then just... Maybe I should do that first. You know what? Let's just get a prototype. Just simple. Just simple. Audio dot start. Audio dot stop. While one chunk equals audio dot read. Audio dot write chunk. For each chunk, volume equals the maximum of the chunk. What happens if I just run this prototype? I'm sorry. I apologize. That was very loud. I was expecting it to be that bad. I kind of took off my headphones. I probably should have said something before that. I hope nobody's on. Nobody's looking at this. Nobody's participating. Nobody's on. Nobody cares. Darn. Well, actually, not darn. That'd be pretty bad. Okay. Whoa. Okay, that's really buggy, actually. What the heck? Why is it so... Not the callback. Just give me PyAudio. Because those have examples. So opens the form into does that wire, which is that one. So, I mean, to me that looks right. You read from the stream that's there. You read it from that by that chunk size. And then you turn it into a buffer. Oh, because I forgot to do something important, which is do that. There, that's much better. Okay. I forgot to turn this to 2 bytes. Like that. So that was important, and I kind of feel stupid for forgetting that. That's okay. Everybody makes mistakes. Now I can put that back, and it's still good. I know it's not there for now, but that's okay. Nah. Cool. I mean, that could stop itself. Anyway, do that. Is there width? Does this support width? Probably not. That'd be stupid. Actually, it wouldn't be stupid. It'd be really nice, but that's the joke. Is why would this library support a context managing or whatever it's called? That'd be stupid. Print volume. Actually, sorry, oops, forgot to rectify it. And then the maximum of the rectified is the volume. Now she just don't bend out of place, Mr. Wire. There's a wire back there. I need to fix that at some point, like somehow. Not sure how. Tape it, glue it. Who cares? Who knows? So turn that off for now. There, okay. And then we'll say thresh equals 0.5. Instead of using volume, if we go by this, so it equals chunk, but then you use a Boolean expression. If it's bigger than threshold, then it will work, or bigger than the gate, then it will work. And if it's smaller than it, then it won't. Oh wait, forgot to turn on this. No, to work. Oh. Okay, but it cuts off like awkward. So it's kind of terrible. Honestly, yeah, it's bad. And that's what I was expecting, because you're doing it with every sample. So you just do that. So you do. So instead we use one volume for the whole chunk. Volume is smaller than the threshold. Continue. Oh, because sorry, wrong syntax. Oh wait. Oh, okay. So it So that's disgusting. That's just awful. I hate it. It sucks. It's terrible. It's disgusting. Oh. Okay. Yeah, that's okay. No. And that's what I was afraid of. I was afraid of it doing that because we're doing choppy voice. You can always smooth out between chunks, maybe. And that's by using chunk look ahead. So instead of doing sample look ahead and stuff, we're doing chunk look ahead. And that might actually work really well. Because then attack and release would just rely on chunk size. So it wouldn't be as configurable, but it'd still work. Oh god, wait, that's funny. And if we just do that, then we can actually do volume equals if we just do and if we set that oh god, it distorts really easily. Sound like Jason now.
Hey guys, it's me, your favorite YouTube.
Oh god. Hold on. Let's just make some funnies.
It's me. It's your favorite YouTuber. I wanna die.
Hold on. Beautiful. That's how he does it. That's how JSlot does it. Is when it goes when the audio when the audio goes above a certain threshold, it just cuts out. It just dips. Beautiful. I hate it. That's good. Good. This is all worth it. Oops, wrong way again. So now it gates.
Oh.
Yeah. Cool. So now it gates. So now we have the gating function. And then we also want the amplifier too. So that's one stage, and then the amplify stage. And this is gonna actually rely. Yeah, okay. So if we print the volume, we print 1 divided by the volume.
Okay.
So if we do 0.04 times 22, then that should be around 1, yeah. Now, of course, if we do that times like 22.03, then it's much closer. We'll prove it. Bam. It's basically the same. So that's the amplification amount divided by volume. And then we do chunk equals chunk times amp.
Ow. Okay.
And that's where the gate comes in to cut things out.
There. Okay. So now it gates when it needs to gate.
And
I can actually just say,
like, times amp. Okay, so it will only amplify. It will only amplify. I'm only amplify it if it's above the threshold.
otherwise,
it won't do anything. So it's times 0.
there. Now it's small.
So now it will
What?
Okay. So
Okay.
wait, no, the maximum is what I want.
So,
Shoot. Okay. No feedback.
So now when it's above the threshold, it will amplify it.
But if
But if it's below the threshold, then
it will just do normal audio and not amplify all the noise because I don't like the noise. Noise is bad.
but voice is good, and so we want to amplify it. Yeah, boy, help me. Huh?
Beautiful. So that will only amplify through the threshold. Kind of cheeky, but here we'll just have it so it will be gated. Equals min 1 amp times gate.
There.
No.
Did it again.
I'm silly.
I'm a silly goose.
So that does do what I wanted to. Epic. Great, fantastic. So we have the application stage and the gate stage, except it's just really choppy. Why do you have to use a volume? If you use the gate, it will become that distorted mess it was before, and if you use this, then it will be okay. That didn't work. there numpy as MP. Ah, up. Dot concat. Concatenate that and 1. Wait, no, append it. Yeah, it will do that. Holy shit.
I wanna die.
Why is it just dying like that? That part I don't understand. Okay, we're about to get really loud. So now it should just distort it.
Like that.
And that's what happens if you do it with instead of sample-wise instead of chunk-wise. So yeah, going sample by sample is usually a very bad idea. At least in cases of simple shit like this. Because it will not work at all. It'll be very bad. No, because I went volume. Cool.
So now it does things kind of.
Except for the part where you do that. Okay.
I wanna die. Have you ever wanted to kill yourself before? Because I always wanna die. Please end my life.
Okay, so see beautiful. Mwah, it works.
It's perfect.
Just die. And if we set the threshold to lower, then it becomes really easily feedbacky, so I have to constantly talk unless your ears want to get pierced, but they're probably getting pierced anyway because it's so loud. So yeah. That took like 2 seconds. Look at all this. It's disgusting. I hate it. I made it terrible and it sucks. Except this one's more choppy boy. I don't like choppy boy.
I do not like the choppy boys. Oh wait. No, so like chop. No goose that choppy.
Help.
I wanna die. Okay.
Oh, by the way, that Kobayashi thing was from my memes folder. If anybody cares, probably nobody cares. Nobody's watching, so it's okay. Okay. So now let's try to linearly interpolate the gateness. But we want to gate ahead of time. So we have to lerp between 2 values. So what we actually want to do is we want to use a gate buffer and not volume buffer. We might use a volume buffer, but we also want to use a gate buffer, I think. In that case, yeah. We want to use a gate buffer, probably. We could also do average. Hold on. First, let's try something. So instead of we want to do the average.
Okay. And now it's slightly different.
Actually, the gate's gonna trigger even sooner because it's doing the average of the waveform instead of the maximum. And if we make the chunk size smaller, then it will probably distort it more. So if we do 256 instead.
Okay, bros. As you can see, it's a lot more distorted. And if we do 64, it just starts like distorting to hell. Beautiful.
And if we make it longer,
then
actually
the longer we make this, the longer we make this,
they will normalize less. So
a nice short one is usually nice, like 104.
Because that gives it time to do things. So now, okay, so we have the last chunk. Don't mean to dot that. The last chunk will be that one. And this is where we should really start plotting things. We're going to configure. We're going to configure that. We're going to configure xlim 0 chunk. Or sorry, audio.chunk. And then we will limit the y to -1, 1. Epic. Now we will not plot anything because this won't work. If we plot chunk, then, and we close it. Well, it won't do anything, will it? Yeah, there it goes. And now it's starting to. Oops. Yes. And we'll do that. Beautiful. Now we also want to do the volume as buffer since we're going to be interpolating. Yeah, boy. So we're going to do, okay. I'm going to set those boys. That one. Okay, so we're going to have 2 empty. So we're going to set a new chunk. Last chunk equals chunk. And we can actually do this one. And chunk.copy. Now I gotta try that. Hold on. We probably just want to do numpy.array. There. And then b equals a 0 equals 1, a, b. And you can see it's that. So we want to do b equals a dot copy. So then if we do b a0 equals 5, b equals a, b 10, 2 equals 3, or 5, or whatever I put. Yeah, so that's definitely not what we want. If you do a equals, I can't. B equals a, b0 equals 1, sorry, 6, it will change both. A1 equals that, it will change both. So you also have to do so the same. A b equals a dot copy, b equals, now they are different. So it is copying that we need to do. We need to make another one. What does copy to do? Oh, instead of making a new one, all right. source. Does it return anything? It doesn't return anything. Return source does where. There. Oh wait, don't plot it. Okay. So, oh wow, that's really. Oh wait, I forgot to do the thing. Nice.
Okay. All right.
So now that works. We could also just be cheeky and do last chunk equals chunk.copy.
But now we're doing a copy every single time, and that might not be the best idea. Like if I do that 5 times,
Then it's still gonna be pretty fast, which surprises me. I mean, I guess Python is faster than I thought. Yeah? Kinda? I don't know. Cool. Epic mama. Okay. Okay. No attribute copy. Okay. Awesome. Okay. So now we have a last chunk, which will be the last one. And so we want to lerp between. We actually want a next one, and it will play. So we can name this because we do want to look ahead. There. So we're actually writing chunk. So first we'll read a little bit of audio. And then we want to do stuff. We want to write the last chunk. So really we're going to imagine this, we're going to pretend that this is future, even though it's not. Then we're going to make that the current chunk, and we're going to get the next one. We're going to do some interpolation. Cool. those. Now we can linearly interpolate between those three. And we eventually do that. Okay. Cool. So for some of them we want to do look ahead, and some of them we don't. For attack, we want to do look ahead. For release, we do not want to do look ahead. We want to do look ahead because that will, even if it might be quieter than it needs to be, it will be normalized. Cool. And we want to construct the volume buffer from those. I in range. My goodness, thank you. Thanks, Mom.
Yeah. What? Well, what do you want? What do you want? What do you want?
Best mom ever. I love her. If you shout out to all the moms. Chunk if you want. Object of too small depth. What? Oh, because my bad. Cast D-type. Oh, I think you can. Did I really just do next pause with next chunk? I did. So that's not going to do anything. The only reason it's not going to do anything is because I forgot to set the buffer. And then it sharply declines. Did I not say here are the constraints? I did. Cool. So it does go up to follow it relatively smoothly. And I could always use attack and release to say if it's going up. If it's going up, then if the volume is going up, then do it early. And if the volume's going down, then wait before moving it down. But I can implement that later. That's not super difficult, I don't think, to implement. And I can actually do all three of these at the same time, which I'll probably do. So now you've done all those. We can do gate buff. We can do amp buff. This might actually work. It would depend on the attack and release would both depend on the chunk size, but it would work. Except the volume would be a little late because it linear interpolates up, but it's a small enough difference and the chunk size can fix that. You don't even need to set that, actually, but it'd be nice to do, just for funsies. Times gate, chunk equals chunk times amp. Gate times amp. Now if we don't plot any of this.
Oh wow. Oh, it actually worked now kind of. Oh, whoa, what's this? This actually kind of works now. Isn't that nice? And it doesn't.
That'd be bad.
Oh, whoa. What's this? It doesn't. It's not stupid.
I'm a Dumbotron.
I'm a Dumbotron.
Have you ever died? Have you ever died? Okay. Oh god. Okay. Oh god. So it still, it doesn't interpolate correctly because I did, because I hit myself.
Okay.
So what is the point of the volume buffer besides? Chunk I equals chunk I. That times gate buff I.
And that. What? It. Kill me. I wanna die. I wanna die. Okay.
Anyway,
Okay.
that should allow, gate times amp buff I.
Wow, that's stupid. You're dumb. Wow, that's stupid. You're dumb.
Nice. Okay. What? That's too bad. I don't like it.
So what is that? Oh god, it doesn't even close to work. Nice.
It's supposed to be like nice, it's beautiful. It's perfect. But it's not perfect. What? Help. Kill me. What? What?
Huh?
Help. Oh. Why? Jesus. How about that one?
Okay. What? Oh. Okay. Why do I exist? Why do I exist?
So it's not being nice to me.
Stop being stupid.
Just me. Okay. That should work. Starts at 1. Actually, I have a better idea. Non-Spanish. Why did it add another keyboard for me? Why does it keep doing that? I need to stop doing that. Hold on. Oh. Where's amplitude? Nowhere. There's nowhere to be found. That's too bad. What's the problem? Unexpected types any ND array. Oh, because I forgot to put them in a tuple. Gay. Sorry, because if you zoom in really closely. Blah 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 blah. Blah blah. So that's getting the next chunk. Chunk. doing is wrong. What does it think the gate is? Ah. Oh, it's not clearing it. Okay. I need it to clear it. Oh.
Oh. Ah. Ah.
So why does figure.clear work? Oh. Oh, geez. Oh, gosh. Okay. Cool. Epic. Divided by 0 encountered. Oh. Yum. Still no one. Where were all those people before? They just left. They're gone. Poof. It's kind of unepic. Okay. All right.
Why?
All right.
Why?
Ah, Christ, I keep forgetting I need to get rid of that. Wow.
Okay.
Wow. Let's just not draw that.
Okay. Okay. Oh. Oh. Huh. Huh. Me, 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 me. Me, 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 me. Uh.
I know I'm asking. I know I'm being autistic. I know I'm that disgusting. Autism. So I think, I know why it's destroying itself. It's because it doesn't clip. I'm using a numpy right here. Clamp. Let's clip it. Let's see if this destroys itself. I'm afraid. Clip. Oh wait, oops. Min and max. Now if we amplify it. So that, damn. Disgusting. Oh god. So clipping doesn't appear to be working. Oh, it's because I'm not. Because you made yourself too tight. If I go like this. Okay, anyway. Here's the thing. Here's the Django. What it's doing here is it's converting this type right here. It's converting that type. So if we say if we do this, that array, and we do there is that's doing that. So if we have a flip 64, if we do that, we have to do some clamping here, clippity clamping. To prevent it from fucky wucky. There. Because if we go, yeah, okay. Is that even working? Okay. There. Now we're not clipping on everything. This is a test. This is a test. So what happens if we don't get it at all? Why is it doing it now? What? It's still clipping. Get rid of the fake. Why is it clipping now?
Okay. Okay. Oh God.
Right.
Huh? What? What? Oh. Oh.
See that? You hear that? That's the sound of something working. Relatively. Okay. Okay. What? Now it's even faster.
Okay. Okay. Oh. 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 Okay. Okay. What? Oh boy. That's kind of sad. Oh no. What? 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 What?
Honestly, 100th of a second is good enough.
Huh?
Yeah.
Okay. Okay. Why do you exist? Why do you exist? Oh.
Hold on. So let's just do gate.
Oh. Okay. Meow.
So that actually works. Kinda. I mean, does it work? So this almost works. Except it kind of flumps it away at the end.
Have you ever died?
I have not died ever. End my life, please, thanks. So it actually does amplify it. Which is epic. No, cancel. What? Epic maybe.
Okay. Okay.
So it does work. If you have a lowish threshold, then it will amplify more, which is good, kind of. There's only one problem, and that's that it starts. It amplifies it. Yeah, it's that. Yeah. Okay, so that's where we have. So it looks ahead, but we have to make it not do that. Crunch. This is stupid. Why am I doing this? 1/5 of a second. What? Have you ever died before? So, now what we have to do is do the special boy. So now what we have to do is say, okay, if something like the gate or the amplifier, if the amplifier is going to get calculated ahead of time, if it goes down. So if the volume, we want the volume to be looked ahead when it goes up, but when it goes down, we want that to gradient. Okay. Currently what it's doing, if you have an awful square wave like that, currently what the volume's doing is it's looking ahead. So to look ahead, say these are chunk lines here. These are chunk lines, and it's finding the maximum volume for each chunk. When it's looking ahead, which means that it is going here, and then it is linearly interpolating between the next one and this one. So it's going like that. But then this one, the maximum of this chunk and the next chunk is that. So it will go down like that. That is what it looks like when it's looking ahead. If it's not looking ahead, then it will go like this and this. So what we want is a combination of it looking ahead when the volume goes up, but not looking ahead when the volume goes down. So here, let's take another chunk like that. So there, it follows it more nicely. And that will be more accurate for graphing. Not graphing, that'll be more accurate for gating and for amplifying, since gating depends on the volume. So actually, this is only used in graphing. So technically, we don't need volume buffer at all, because we can just interpolate between the gate and the next gate. We don't need to know the different values like that. So we don't actually need that. Problem is, how are we going to get it to look ahead? Maybe what we can do is that, again, this all depends on the volume buffer. the volume thingy, but thingy-majig. All depends on that. All of this, I think. So, if next volume is higher than volume, then we want it to do this look ahead boy. We want it to do this one, look ahead method. But if volume, this is volume, this is next volume. If that's higher, if this is higher, if volume and is lower than next volume, or if next volume is higher than volume, then we want, maybe it's a bad idea naming this chunk and next chunk. Okay, if next volume is bigger than volume, then we want to do the look ahead method of going up beforehand. But if next volume is smaller, then we want to shift this or we want to apply this linear interpolation to the next chunk instead of to the current chunk. So can I just do that? No, yes. Yes, I can. I think. I believe so. Let's try that. Let's try that. Next volume is bigger than volume. Then we're going to apply it to the current chunk, do the look ahead method. Elif, next volume, I don't know I'm doing Elif, but I am smaller than volume. Chunk, next chunk I. So we're going to apply it. Chunk I times equals this times this. Else, we want the next one. The next chunk is going to be affected by it. Oh, if they're equal, which they're very rarely going to be, then if they're equal, well, I mean, that's fine. Either method works, probably in that case. Yes. Oh, assignment destination is read only. What? Destination. Copy to. Chunk equals next chunk. So next chunk. Bring to. It's gonna be read only now. Whoosh, 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 whoosh. Okay. Alright. Sorry. These are going to be what are the T types? Two and float 32. Assignment destination is real. What does that even mean? Yes. Yes. Die. Beautiful. Beautiful. Now. It should not. It should not. What is it sidechaining? What is it sidechaining? No. That's not working. That is not working at all. I have to sleep. I'll have to figure this out later. Nobody's watching these streams anyway. Does it even matter? Yeah, I'll just keep doing it. You know, no harm. I'll be back in like an hour or so, probably. See ya. Nah, I actually changed my mind. I'm gonna end the stream, and I might do other streaming soon on something else. So, see, senor. Yeah, I'm probably gonna, yeah, okay. See ya.